All right, 10.5 is graphs of quadratic equations. If you've done a little bit of plugging in and creating graphs, but what you should be kind of gathering out of 60 and 65 is that certain equations have certain pictures that go with them. For example, in 60, we looked at y equals mx plus b. There were other forms of it. There was ax plus, oh, I'm botching that one, sorry, ax plus by equals c. That was the standard version, formal, dressed up version. We've got your friendly instant graphing version here, y equals mx plus b, and then there was your point slope form, y minus y equals m times x minus x. These all created lines, and that's why they were called linear equations. Their picture, you could predict what the picture would look like based on what the equation looked like. Same idea here. There's a basic picture that goes along with quadratic equation. So the basic graph of a quadratic is kind of a U shape that comes to a point. It's called a parabola. Bonus points if you knew that right away. A little gold star for you if you already remembered that term. And some things to note about the parabola, it kind of has a little curve to it, but it does come to a point. We call that point the vertex. And it can face up or down. They can be really wide or really slim. They are symmetrical though. And they're symmetrical around that vertex. They're the same mirror image on both sides. There's some things that we can determine just by looking at the equation of a quadratic. Just by looking at it, we can determine if it's going to be facing up or if it's going to be facing down. If our a value is positive, then it's facing up. If our a value is negative, then it's facing down. Okay. And again, this is when your equation is in standard form. So when you have a quadratic equation of ax squared plus bx plus c equals 0, that a value is what we're talking about here. If the a value is positive, if the a value is negative, then you can predict how that final picture is going to look in terms of going up or going down. And then another way to help determine where this is on the graph, because what we've done at this point is to create a table, right? Where here's your equation, you picked some x's, you picked some numbers, you plugged them in. Okay, you did all kinds of calculations, and then it spit out a y value. And then you'd have all your x, y points that you would then place on the graph and play grown-up connect the dots here. Kind of tedious. Can take quite a while, and one little mathematical arithmetic error and your whole graph is off. So, and if you remember way back in Math 60, that's kind of how we started with the lines too. We'd pick some x's, plug them in, get our y values, connect the dots. Didn't take us long to realize, hey, it's a straight line. So we realized, hey, I can just get 2 points. Let's get the intercepts, x-intercept, y-intercept. And then we graduated to this instant graphing, the slope-intercept form of the line, where we could look at these two key pieces, the b value and the m value, and the b is where we began our graph, our y-intercept, and then m is our slope. That's how we moved from that beginning point to our next point, and then we can connect the dots and the line is done. So instant graphing here with our y-intercept and our slope. Right? And that should have been a glorious day as you learned how to take care of how to create graphs of lines practically instantly from the equation. Well, we're going to try to get to some glory days here with the quadratic equations as well. Gone are the days of these big tedious tables. Pick some x's, plug them in, get our y values, put points on the graph, connect the dots. Because we're going to use our power of algebra here to come up with some key parts of the parabola instant graphing. Okay? And when we come to class about these, I'll show you even more in addition to what we have on the notes here. Just a little Mrs. Michael bonus for you. Okay, so now we know right by looking at it if it's going to be positive or negative A value, and so if it's going to go up or down. The next thing we actually know how to do, we haven't called it this yet, but we actually already know how to find the X-intercepts, where it crosses the X-axis. So let's say you have a parabola that the graph looks like this. We already know how to find these two values. The X-intercepts is where it crosses the X-axis. It's where y equals 0. So whatever this number is, comma 0, and whatever your other x value is, comma 0, those are your X-intercepts. Well, how do you get how do you get y equal to 0? Well, that's in standard form. From standard form, ax squared plus bx plus c equals 0. There's our y equals 0. So solving for x, all the stuff we've been solving for, factoring and zero product property, square root property, completing the square, which was bonus in 10.2, and now quadratic formula, all that solves for x, and it gets you those X-intercepts. So if you go back and look at any of the problems we did where we solved the solve for x from a quadratic equation, we were finding the X-intercepts, where the parabola crossed the x-axis. So we know how to do that. We aren't learning anything new, we're just learning that that's what it creates on the picture. So that's exciting news. The next piece is the y-intercept. It'd be nice to know where it eventually crosses. Now I didn't draw a great picture here, but eventually this would keep getting wider, and somewhere up here this graph would probably cross the y-axis at a y-intercept point, so that'd be great too. Well, if same as lines, x-intercept is found when you let y equal 0. The y-intercept is found by letting x equal 0. And the cool part about letting x equal 0 is when you have standard form again, y equals ax squared plus bx plus c, where this is your y value. As soon as you let x equal 0 here, a times 0, that's just going to wipe out and be 0. You put 0 in for x over here, 0 times anything is 0. Your y value just becomes c, so that's the piece that's left over. So your y-intercept is going to be 0 for x and just your c value. No math needed, it's just instantly there. So your y-intercept is up here at 0, c. And the final piece that we're going to look at to help us create the graph without having to do the tedious table is the vertex. And that's the point right down here. And this actually comes from the idea of it being symmetrical, and we're going to utilize what we know from the quadratic formula. Now, I'm not going to take the time to prove this. I think the book walks you through it a little bit. And it's something I'd be happy to investigate. If you want to have some really deep math nerdy conversations, I would love to do that with you. But for now, I'm just going to hand you the formula, and we're going to go from there. So the vertex, and now we're looking for a particular point xy, and this is the turning point of the graph, or the turning point of the parabola. Okay, and so there's two coordinates here, your x-coordinate and your y-coordinate. The x-coordinate is found by taking your negative b over 2a, where b is your value in front of your x term, and a is your value in front of your coefficient in front of the x squared. Again, you keep the sign of the b, and then you do the opposite of that. So it's the opposite of b divided by 2a. Now if you think of it as negative b over 2a giving you that workspace, then you just plot b directly in here, keep the sign of b, and then let the formula make it the opposite for you, and then put your a inside there as well, and then divide. And that will give you your x-coordinate. once you get your x coordinate, then y equals whatever number you get from plugging your x coordinate that you just found into your equation. So you'll get the x coordinate by taking negative b over 2a. That'll give you some value. You'll take that value, put it in for x here, solve for y. So you'll have ax squared plus bx, put whatever your a, b, and c are, square your x, multiply by a, multiply x by b, add all three pieces together. That will give you your y coordinate, and then you'll have your vertex x, y. Okay, so that's kind of the verbal talking through here. We're going to do, we're just going to get there in baby steps. So we'll go to the next part of the video here by looking at the bottom part of the page.